Assalamualaikum, good morning, good afternoon, good night, good evening. Welcome back to BEKU 2333 Electrical Circuit 2. Now we are in Chapter 5, Two-Port Networks, Impedance Parameter. Alright, so what is a port? We're not referring port to the internet connections, but we're looking at the electrical terminology for port. It is a pair of terminals through which a current may enter or leave a network. So what is a two-port network? It is an electrical network with two separate networks for the input and output. And what is a linear circuit? Linear circuit is a circuit whose output is linearly related or directly proportional to its input. Looking at diagrams A and B, the linear network has connections to two terminals, and in B it has four terminals. So one port is a two-terminal circuit, as in diagram A, while two-port or four-terminal circuits is shown in diagram B. It is an electrical network with two separate ports for input and output. So two-port network can be characterized by two types. One is the driven by voltage source or driven by the current source. Now we're going to talk about impedance parameters. Looking at diagrams A and B of the voltage or current source in the linear network, let's try to assume there's no independent sources in the network. And we can say that the voltage across terminal 1 is equal to Z11 I1, the current, plus Z12 I2, and V2 equals to Z21 I1 plus Z22 I2. If we arrange this in a matrix form, we have Z11, Z12, Z21, and Z22, and this can be characterized as just Z. The Z terms are the impedance parameters, and they have units of ohms. Alright, looking at this diagram, this is a way how do we figure out or find out the values of Z11, Z21, Z12, and Z22. So the first step is to obtain Z11 and Z21. We connect the voltage V1 across terminal 1 or port 1, but port 2 we leave it open circuited. Now why is it open? Because we want the current to become 0. It's easy for us to calculate Z11 and Z21, and it is obtained as shown. Z11 is V1 over I1 at I2 equals to 0, or Z21 is V2 over I1 at I2 equals to 0. Now what is Z11? It is the open circuit input impedance, while Z21 is the open circuit transfer impedance from port 2 to port 1. You can see in the equation Z21 has V2 and I1, so it is the transfer impedance, but Z11 is the open circuit input impedance. Right, moving on. To obtain Z12 and Z21, this time we have to open terminals for port 1, in which it will make I1 become 0, but V2 will connect a voltage source, and we will obtain Z12, which is V1 over I2 at I1 equals to 0, and Z22, which is V2 over I2 at I1 equals to 0. And Z12 is the open circuit transfer impedance from port 1 to port 2, and Z22 is the open circuit output impedance. Why is it called transfer impedance? It has V1 and I2. The output impedance is because it's only measuring across V2 and I2. Now let's look at an example. So we have these two-port networks. It contains purely resistive elements, 20, 30, and 40. Labels I1, I2, V1, and V2 are in the two ports. And we can get the terms Z11, Z21, Z12, and Z22 using the given formula. And let's look at one by one. So Z11 is V1 over I1. So imagine that I2 is open circuit, So you will have V1 over I1 is actually 20 ohms plus 40 ohms. That makes it 60. What is Z21? Z21 is V2 over I1. So it is only 40 because I2 is open circuit, right? And Z12 is V1 over I2. V1 over I2 is also 40 because at this time I1 is open circuit, and Z22 is V2 over I2, or the total number of resistors from 30 and 40 will give you 70 ohms. Alright, let's try another exercise. Obtain the Z parameters, impedance parameters for the network below. We can see 4 resistance, 1 ohms, 4 ohms, 6 ohms and 2 ohms. And to solve this, first as usual, we'll try to get Z11 and Z21. Looking at figure A, you can see that there is a current source connected across V1, and for V2 it's left open, so the current I2 is equal to 0. Knowing that Z11 is the open circuit input impedance, we can obtain it by looking at the equivalent resistance, which is 4 and 2 is in series. It is in parallel with 6 ohms, and lastly added with 1 ohm. And by doing that, we get Z11 is 4 ohms. For I0, it is half of I1 because it is obtained by using the current divider. And you can see that 4 and 2 ohms or 6 ohms is in parallel with 6 ohms. So both will have the same magnitude of current. So that's why it's half of I1. And V2 is equals to 2I2, to the resistance at the branch I0, multiply with I0, we get V2 is equal to I1. And Z21 is V2 over I1, that is 1 ohms, because we have from the previous equation, V2 equals to I1. Right, moving on for Z22 and Z12. This time we're going to connect I2 current source to V2 and leave V1 terminal open. So in that will make I1 equals to 0. And we know that Z22 is open circuit output impedance. Thus Z22 is equal to V2 over I2, and that is 2 in parallel with 4 plus 6 ohms. Note that 1 ohm is not is neglected because the current is 0. And by doing that, we have Z22 equals to 1.667 ohms. And IO prime is equal to 2 over 2 plus 10, because you can see it's a current divider, 4 and 6 ohms in parallel with 2 ohms. And that will make IO prime 1 over 6 I2. And V1 is equal to 6 IO prime, and that is equal to I2. Thus we have Z12 V1 over I2, which is equal to 1 ohms. So remembering all these values that we have obtained, our impedance parameter becomes 4 ohms, 1 ohms, 1 ohms, and 1.667 ohms. Alright, let's go through another example. Example number 2. Calculate I1 and I2 in the figure below. You can see that the impedance parameters are all given. Z11, Z12, Z21, and Z22. And we have a voltage source which is also given. And that includes 2 ohm resistors. And at the output port, V2 is short circuited and I2 coming into the 2-port network. So the solution is we can straight away write down the equation from the impedance parameters. V1 equals to 6I1 minus J4I2, and V2 is minus J4I1 plus 8I2. Note that the terms J are the imaginary J. And we also know that V2 is equal to 0 due to the short circuit, and the voltage 2 with an angle of 30 degrees is equal to V1, and that needs to be added with 2I1 coming from the 2 ohm resistor and the I1 going into the 2-port network. So we have V1 is equal to 2 with an angle of 30 degrees minus 2I1. And we'll put in 1 into 2, equation 1 to equation 2. We will have 2 angle 30 degrees minus 2I1 equals to 6I1 minus J4I2. So this is actually the V1 equation. And if we arrange the terms, 2 angle of 30 degrees is equal to 8I1 minus J4I2. That is a new equation. And we look at equation number 2. We know that V2 is equal to 0. So 0 equals to minus J4I1 plus 8I2. And then we will have I1 is equal to minus J2I2. Right, and we know that these are the properties of the powers of the J, or the imaginary term. And if we substitute 3 into 4, we will obtain 2 angle 30 degrees is equal to minus J16I2 minus J4I2. And that is equivalent to minus J20I2. And we solve this, we will get I2 is equal to 2 angle of 30 degrees divided by 20 angle of minus 90 degrees. So where does the minus 90 degree come from? That is from the minus J term. And we'll get I2 is 0.1 angle of 120 degrees amperes. And if we use equation 3 to solve this, we can also get I1. I1 equals to minus J2I2, and that is equivalent to minus J2 multiplied with 0.1 angle of 120 degrees, and that gives us 0.2 with an angle of 30 degrees amperes.